Yeah, so my name is Marion, and I made a classifier for motor imagery. So just if you're not familiar with what motor imagery is, it's so EEG, we already talked about that, but you record electrical activity along the scalp and so I'm working on my free time with the Berkeley Cognitive Technology Group. We're getting this EEG data from a board called OpenBCI, which is a very cheap medical grade open source EEG recording device. And what we had at a recent hackathon was a quadcopter that was mind control with EEG recording of motor imagery. Motor imagery is like recording you when you're moving your left arm, your right arm or your left arm, and then if you just think about it, your brain actually makes the same patterns. So the idea is to have a system that will then recognize you just thinking about that, and that way you can potentially control things with your mind. So just to show you what we did with the basic machine learning classifier, it actually worked pretty well. I mean, it's like 50% accuracy, but it was like a nice breakthrough with this open source device. So here's Thomas with his little electrodes on his head. And that's pretty good because like it's 1 second, like your eyes can see one second latency, it's fine for this type of neurofeedback, and so in the end the app worked pretty well. But we want to increase this accuracy 50%. If we can get over that, you have potentially a lot of amazing applications. For example, for the disabled, like controlling wheelchairs with their mind is like really amazing. So I really wanted to try NuPIC to see if you're going to get crashed by this quadcopter. But yeah, so the idea is to use NuPIC to get hopefully higher accuracy rate.
How many things was he trying to classify just then? Just 2?
3 things. No movement, left arm and right arm, which is actually exactly what I'm trying to classify as well. And I'm using the same data set as a benchmark to compare it to this like kind of more classical machine learning approach. And so we have 8 EEGs, channels. As you can imagine, not all of them are useful. And you have three phases, so no movement, left hand and right hand. Sampling rate is 4 milliseconds. And so I guess I can show you a demo of how NuPIC did. And so, actually before that, I want to explain a little bit how I massage the data. So talking about, with the Numenta people, like I got a couple of insights about how I could do that. And the idea is to create 1 model per channel per phase, so left, right, no movement. So 3 models per channel. And then we disable the learning at the end of each phase so that we can, when we feed a new incoming EEG data, we can see whether the anomaly rate is high or low, and then we can pick the right model that gives the smallest anomaly rate, average over this period. And so this is how I made prediction with NuPIC, feeding EEG data to the 3 levels per channel, no movement, left, right, and seeing which one had the lowest average anomaly score. Okay, that doesn't work. So then, if I can first show you the prediction part because it helps having an idea how well it performs. And so what we're going to see is 1 channel data stress loading because there is quite a lot of data. And like NuPIC has been trained already, and I'm loading the model that has been saved. And in the end, the data is very spiky because it's very dense. In the end, 4 milliseconds is like pretty high sampling rate, but it's like, in my opinion, it's doing quite a good job. But then the next part is actually amazing, and I just before this demo I got it working, and I was so happy because then the classify part is really cool because it's actually so far 100% accuracy, so it blew my mind. So I need to reevaluate that afterwards, but I can show you that, and then really I'm feeding it 400 milliseconds of data, and then it's going to give me, wait, I'm not the right thing here. I want to turn on classical. So it's saying, so I'm seeing EEG data that's coming from one channel, channel 0. So let's classify this EEG data. The guy is not moving. And it's actually predicting that we tried the 3 models, and the lowest anomaly, like average anomaly rate, is actually no movement. So that's cool. But then let's see the motor like actually moving your hands. And the same like left hand is actually the lowest anomaly score as well for the data incoming from when the patient is actually not moving at all. So far like it hasn't failed to not predict well, let's say, even though it's like pretty spiky. So I'm really happy with this. I can show you again the more like graphical.
That was over 400 milliseconds of data?
No, I trained it over.
No, but those counts, I can't.
Yeah, these little pieces.
So you did one sample for each?
So I took 100 data points.
But you did a bunch of them?
Yeah, I did a bunch of them.
Yeah.
And so this is like over, I think, 25,000 data points. So during the training phase, it's eating like 25,000 data points per channel, per phase. And then after that, each time I get an incoming EEG signal, I take just a little chunk of during 400 milliseconds and I feed it. And then it's giving me this result.
Yeah.
That's really cool.
Yeah.
Nice.
That's we've been talking about doing classification using anomaly models like this for a long time, and I think this is the first time we've actually seen it work, right?
I'm
We've seen that from the community. I mean, yeah.
Yeah, so when it worked, I was like, yes, this is going to be so great, because this is a game, right? But for actual application of this is going to be amazing.
And you think one channel is actually enough?
No, I think if we actually combine all of them, I can actually reduce, not take like as much as 400 milliseconds, and I can potentially, I hope, again, I need to investigate that, but take a smaller amount of data and then combine kind of like all of my anomaly scores. Channel 0 is actually like, it's like a useful one, but then my assumption is that if I combine all of them, it's going to be really good.
You can probably process all of this data streaming and be able to classify in real time. You could calibrate, put the EEG on,
yeah,
calibrate.
Exactly. So this is actually why there are like 2 phases. One, training, where exactly like what you did, right? I train it on a data set that is the training phase where we tell the guy, okay, move your left hand, move your right hand. We feed it to NuPIC, we freeze the model, so that's the training part. And then after that, you're just streaming in new data. What could actually be also a cool thing is to create little batches of like updated data, like kind of recreate, like kind of post-streaming data set. Let's say the quadcopter, we have like a feedback system, it's indeed going left or indeed going right. I could, once the classification is made and I'm happy with what I'm seeing, I could kind of label this predicted data as being valid and then put it back in a data set to continue training the model so that it would reinforce itself over time.
Awesome. Yeah, good job.